Thank you for completing the Collaborate board. So what is the relationship between the angle formed by the chord and tangent and the intercepted arc? Right, so here's our angle formed by the chord and the tangent. Notice the vertex is on the circle. I notice the angle that's created is 35 degrees. The arc that's located inside the angle there is 70 degrees. So I notice that the angle is 1/2 the measure of the arc because 35 is half of 70. I also notice that the arc is 2 times the angle because 70 is twice 35. And I think we've discovered the relationship between an angle formed by a tangent and a chord and the intercepted arc. So this page coming up is in your notes. All right, so tangent chord angles. So an angle formed by an intersecting tangent and chord has its vertex on the circle. So right here at B is the vertex of our angle. Of our angles, there's 2, right? We have 2 angles formed. We have this angle here, and we have this angle here. That vertex is also the point of tangency for the tangent because a tangent only intersects a circle in one point. So that's it. Right, so the tangent chord angle is equal to half the intercepted arc. So that means that the measure, and this is in your notes, the measure of angle ABC is half the measure of arc AB. And we see that we have an X there for angle ABC. That's going to be equal to 1/2 the measure of arc AB. We can see it from our graph. So here's arc AB. I'll just kind of outline it. There it is. Oops. That could be a little straighter. Right, so that's 120 degrees. So half of 120 is 60 degrees. So put this in your notes. Right. Let's find the measure of y and use that to find the measure of arc, and I'll outline it. Arc ADB. So this is the intercepted arc for the angle marked with the y. Right. I'll outline the angle here. So here is angle y. And over here, we have angle x. All right, so we found angle x. That was 60 degrees. Let's find the measure of the arc first. Let's find the measure of angle y, and then we'll use that to find the measure of the arc. So notice that together, x and y form a straight angle. So x plus y is 180 degrees. So x is 60. That means y is 120. Right, so we'll mark that on our diagram. X here is 60 degrees. Y is 120 degrees. So that adds up to 180. And now we can use the other formula to find the measure of arc ADB. So arc ADB is equal to 2 times the measure of the angle. All right, so the angle there, we'll just put 2 times angle y. Doesn't really, I don't have 3 letters there to name it with 3 letters, so we'll just call it angle y. So it's equal to 2 times angle y, we know that y is 120 degrees, and that means that arc ADC is 240 degrees. And notice that if we were to add those values up, 120 plus 240 equal the entire circle. So we had more than one way to find the measure of arc ADB. We could use the tangent chord angle and double it, or since we already had arc AB, we could simply subtract that from 360 and we would find the measure of arc ADB. So what other angle has this exact same relationship with its arc? You can add this to your notes as well. That's the inscribed angle. So technically the tangent chord angle is a type of inscribed angle. Right? But because it's formed by a tangent and a chord rather than two chords, the arc the angle goes off the circle, and the arc goes from the end point of the chord where it intersects the circle to the vertex where the tangent and chord intersect. All right? So we're going to use the formula tangent chord angle equals half the arc, or the arc equals, let's add that to your notes as well. Add this part to your notes too. The arc equals 2 times the angle. Right, we know it's the intercepted arc and the tangent chord angle because we have it written right above the other formula. Right, so we can use, so if we're looking for the measure of the angle, we should use tangent chord angle equals half the arc. If we're looking for the measure of the arc, we should use arc equals twice the angle. And I just have a few problems. Besides this problem, there's only one other in your notes. And it's not, actually it's one of the easier ones. I should have put one of the harder ones in your notes. So this is the one in your notes. All right, so we want to find the measure of angle 1. And you have everything in your notes. All right, so angle 1 is right here. Angle 1 is going to be equal to half the measure of arc AB. Arc AB is the intercepted arc, and I'll outline that so you can see that. I think in the beginning it's a little harder to see those because you're not expecting it to go like that. All right, so there's our intercepted arc. Since the measure of the arc is 90 degrees, that means angle 1 is 45 degrees, and that's all there is to that one. Let's find the measure of angle 2 right now. All right, so we can use the fact that angle 1 plus angle 2 add up to 180 degrees to find the measure of angle 2. Since angle 1 is 90 degrees, since angle 1 is 45 degrees, I'm looking at the arc measure there, since angle 1 is 45 degrees, then angle 2 is going to be 135 degrees. And now let's find the measure of arc ACB, and then let's check with what we have for arc AB, does that make sense? And I do want us to solve it from the angle here, just so that we can practice the relationship. So here's angle 2. By the way, this is the intercepted arc for angle 2. It goes from where the chord intersects the circle all the way back to the vertex. Notice that the two arcs together equal 360 degrees. And maybe we'll add that to your notes as well. So if we want to find the measure of arc ACB, we could use the fact that arc ACB is equal to twice the measure of angle 2. And since the measure of angle 2 is 135 degrees, the measure of arc ACB is 270 degrees. Now, does that make sense with what we found for, what we were given for arc AB? Well, together, arc AB plus arc ACB should equal 360 degrees. Now, I'll just put an entire circle. And let's check. So arc AB was 90, arc ACB was 270, and indeed that does equal 360 degrees. So that checks out. Right? Let's do a couple more problems. Oh, I got a little glitch here. All right, just waiting for there we go, for the page to turn. Had a little glitch there. This is one I kind of wish I put in your notes. It says notes though, and I didn't see it in your notes, but maybe it is in your notes. Since I have notes there, you know what, if it's not in your notes, I'll try to print it out and give it to you in your notes. All right, so we're given that AC is a tangent. We want to find the value of x. But we don't have any numbers there to find x. So we're going to have to find y first. If you remember in the last problem, the two arcs that are created by the tangent chord angle equals the whole circle. And that's always going to be true. And that would make sense, right? Because the two angles together, oh, we don't have another angle here, but if we continued the line, we'd have two angles that added up to 180 degrees. And the arc is twice the angle measure, right? So if the angles add to 180, the arcs should add to 360. All right, so if we notice, if we add those two arcs together, we have the entire circle. All right, so that means that 3y plus 2y equals, excuse me, why do I want to keep saying 180 degrees? 360 degrees. The whole circle. So that means 5y equals 360. If we divide both sides by 5, y will be 72. All right, so now we know what y is, but that's not the measure of the arc. Right? Here's angle x. Right? The green arc is the intercepted arc for angle x. So we're going to have to find the measure of that arc. All right, well, we know what y is, so the arc that we need is equal to 3 times 72, or 216 degrees. So now that we know the measure of the arc, we can find x. So x is equal to 1/2 the arc, or 1/2 of 216 degrees, or 108 degrees. And there we go. We have found it. All right, so it's not too difficult to work with tangent chord angles because the two angles together add up to 180 degrees. The two arcs together add up to 360 degrees. The arc is twice the angle, and the angle is half the arc. Let's see, do I have any more? This isn't a very long lesson. I think this is the last one. Oh, this is a good one. I have this one in the notes too. And I didn't see this problem in the notes, so maybe I will print it out. All right, so the tangent chord angle, remember, is half the intercepted arc. We need to find the measure of, so I don't know if it's clear here. 5x is the angle. And 9x plus 20 is the arc. All right, so we want to solve for x. Now, how are we going to do this? Well, remember, we can use our formula. The angle equals the arc. We could also use the formula that the arc is twice the angle. Let's write both and see which one looks nicer to solve. All right, so if we use angle equals half the arc, we have 5x equals half, and the arc is 9x plus 20. I don't mind taking half of 20, but if we multiply 9x by a half, we're going to have a fraction to deal with, and you may not want to solve the equation with a fraction. Let's look at the other equation. I could also use arc equals twice the angle. So the arc is 9x, so arc is 9x plus 20. equals 2 times the angle, or 2 times 5x. Well, I think I'd rather solve that one, right? Because instead of having to distribute a half, now I only have to distribute a 2, and that's not so difficult. So I'm going to move this one over just a little bit. Let's solve this equation instead, because that will be a little bit easier. Now I even put that in there. Easier. So let's solve that one. All right, so we have 9x plus 20 equals 10x. Subtract 9x from both sides, and 20 equals x. All right, so now we can find the measure of the inscribed angle and the intercepted arc. All right, so we'll just plug it back in. All right, so the angle, let me move this down. Oops, not so easy. They're attached. All right, so the angle is going to be 5 times 20, or 100 degrees. Now we know we're right if the arc is going to be 200 degrees, right? Because the arc is twice the angle. The arc is 9x plus 20. So let's plug in the 20. 9 times 20 plus 20. That's going to be 180 plus 20, 200 degrees. And notice the arc is indeed twice the angle. So we have set this one up correctly. I think that's the last problem. I'm just going to check. And I feel really confident it is. And it's taking a while. Yep, that's the last problem. All right, so thanks for watching, and bye for now.